Hello, it's dumplet here. Here's an item on geometry. Given this figure, AD is a diameter, EF is a tangent to the circle. Find the length of CF and find the angle DAF. So find the angle alpha. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Right, so let's take a look at the two primary givens, that AD is a diameter and EF is a tangent. Now, tangents and diameter, which is technically the same line as the radius. So AD being diameter and EF being a tangent, specifically at point D, it's going to give us a right angle. Specifically this angle over here, angle AD would be perpendicular to EF. So that's going to be our primary observation. So that's going to be a right angle over here. Next, what we're going to do is, since we have a circle and a lot of segments, it is expected that we are going to use the power theorems. So let's try to get as much as we can, and let's try to incorporate this part first, segment AE, since we have AB and BE both given. So by the power theorem, this should hold true. This should be true. EB times EA, that should be equal to ED squared. So we can get the value of, we can get the length of ED. So ED squared would be equal to, EB is 8, and then EA is the entire thing, so 8 plus 4. So 8 times 12, so ED squared would be 96. And this would give us that ED is the square root of 96. Now 96 is 16 times 6, so the 16 is a perfect square. We can bring the 4 out, so ED would be 4 square root of 6. Now we can try to get more information now that we have ED squared using the Pythagorean theorem. Since we have a right angle here, triangle AED, this would be a right triangle, so we can use the Pythagorean theorem. So ED squared plus AD squared would be equal to AE squared. Now AD squared, we already have it, it's 96. So AD squared would be equal to AE squared. So AE is 12, so AE squared, which is 12 squared, that's going to be 144. And then we subtract the 96 from the ED squared. So from this, we're going to get that AD squared would be equal to 48. And taking the square root, we're going to get AD is going to be, well, 48. It's actually 16 times 3. So we can bring the 16 out of the square root, so 4 square root of 3. All right, so we're kind of close to getting alpha and the value of x now, because we're trying to get as much information as we can. So what we now have to do is just to focus on triangle ADF. It is also right, and we can still use the power theorem and the Pythagorean theorem. So AD is the diameter, so that's going to be 4 square root of 3. So we can also get the radius, but we're not really asked about the radius anyways, but at least we can get those information using the theorems. Alright, so now we're going to focus on the other right triangle that we haven't used, and we haven't used this length of 6, so hopefully we'll be able to incorporate that. So these two theorems again is going to apply. I would be able to get that AD squared plus DF squared equals AF squared, and this is by the Pythagorean theorem, and then by the power theorem, the F squared would be equal to FC times FA. Now the thing is, we have quite a lot of unknowns here, and for example, DF, which is part of both equations, we don't have that. So I guess what we can do is just, let's say DF is going to be another variable y. So let's just say CF is x, and then DF is y. And we have two equations that we should be able to form, and hopefully that's enough for us to get x and y, so like a system of equations. Anyways, so let's try to use the first equation, AD squared, which we already have AD, but we already got AD squared in the previous slide. It's 48. So 48 DF squared, well, that's just going to be the y squared that we have here. So 48 plus y squared, it's going to be equal to AF squared. That's going to be x plus 6, the square of x plus 6. That's from the first theorem, the Pythagorean theorem. And then from the second one, the power theorem, df squared y squared, that's going to be equal to fc, which is x, fa, the entire thing, the entire thing over here, that's going to be 6 plus x. So I just write x plus 6 over here. Right, we have these two equations, and we can kind of see a common y squared. That's going to be the motivation. We're going to substitute y squared here with x times x plus 6. So that's what you see. That's the substitution you see here. And we can try to expand this. We can try to expand this both sides, so we're going to get this. So apparently this is just going to be an equation in terms of x, and we can do the cancellation here, the x squared, and it's going to be just solving for x. So 48 plus 6x would be equal to 12x plus 36, and we can easily get from here that 6x would be equal to 12, and then x would here be equal to 2. X here would be equal to 2. Right. So x would be equal to 2. So we're done with the getting CF. So all you have to do now is just try to get what alpha is over here. So but before this though, we can try to get y, since we already now have x. So we know that y squared would be equal to 2 times 2 plus 6. 2 times 2 plus 6, well, 2 plus 6 is 8. So 2 times 8, that's going to be 16. Right, pretty interesting. It's a perfect square. That's pretty nice for us. So y here would be equal to 4. So y here would be equal to 4. Now there is something interesting here, because yes, we can try to use trigonometry here. But what we can notice is that the ratio of the sides inside triangle DEF, let's just try to write down the 3 sides. It's the 4. It's 4 square root of 3, and 8, which is 6 plus 2. So 4, that's one side, 4 square root of 3, and then here we have the 8. So if we try to take the ratio, we're actually going to get 1 is to square root of 3 is to 2. And it's a very common scene in trigonometry, actually, to see like the ratio of the sides being 1 is to square root of 3 is to 2. This suggests a 30, 60, 90 triangle. So a 30, 60, 90 triangle. Now the angles are determined by this, the angle opposite to all of these 3. So we know that the angle opposite to 4, the side with length 4, it's going to be 30. Same for the 4 square root of 3 and the 8. So in this case, angle alpha is opposite DF, which has a length of 4. Therefore, we can conclude here that alpha will be equal to 30 degrees. Now, in fact, DF, this angle, angle DFA, opposite of the length with, opposite the side with length 4 square root of 3, is going to be the 60 degrees. And obviously, since this is a right angle, that's going to be the 90 degrees. So we have a 30, 60, 90 triangle in this figure over here. Anyways, so to wrap up, CF here would have a length of 2, and angle alpha here, angle DAF, would be 30 degrees. And these will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!